Hey, everybody. I'm Dave Heller, WHYY, along with Derrick Pitts, Chief Astronomer at the Franklin Institute. And if you're regular listeners, you might be wondering what happened to Skytalk, heard Saturdays at 9:30. Well, we're on a little bit of a COVID-related hiatus, but not to worry. We are here now for the next hour and eager to have you aboard, and we'll take a stab at your questions. Derrick, I have a problem, though. It's been a while since we've chatted, and gosh, it's June 10th, and we're only about 10 days out from the days starting to get shorter.
I know, Dave. It's amazing, isn't it? It's been since March when we last had an opportunity to
Yeah.
bring everybody up to speed on everything that's happening in the sky. And it seems as if we've sort of like flown right through spring. And just like you mentioned, in just 10 days, we're coming up on the summer solstice. The summer solstice. Some people think of the summer solstice as being the midpoint of summer, particularly over in Europe and in some of the northern climates over there, because the way things go from that point on, well, once we get to that point, we've reached the peak of the amount of minutes, hours and minutes of daylight that we're going to have. And I don't know how to say this, Dave, but from about a week after that, we start losing minutes of daylight. So this is a perfect opportunity for all of us to really enjoy this beautiful evening time when we have sunlight so late into the evening. And the warm temperatures also make it nice for us to be out.
Well, I don't know. I don't want to be a Davy Downer, but should we rename this year's solstice a Midsummer Night's Nightmare rather than
You
a
know what?
dream? It's been quite a spring.
It has been quite a spring, you're right. No one ever expected that we'd have a pandemic that would throw us into a situation like this, in which, even the kind of work that we've been doing on the radio for so many years had to go on hiatus just to accommodate the protocols to keep everybody safe. And of course, we totally understand that. But, at the same time, we can think of it as a midsummer night dream because eventually this will all be over. And since it's midsummer, we can spend some time outside dreaming about the universe and dreaming what things might be like in other places around the cosmos.
And of course, the heavens above will be waiting for us when we're ready for them. And hey, I thought it'd be really overcast tonight, but I'm seeing some blue sky. So fast forward to nightfall and let's take a stab at it. What's there to be seen?
Aren't we lucky that the evening is so nice so far? I'm not worried about lines of thunderstorms or anything like that.
Yep.
And since it's warm, as we said, it's a good time to be out. But here we are now. We are right at the end of spring. So in the springtime sky, we're at late spring, about to switch over into summer. And what's interesting about the evening sky is that the changes that take place of what constellations we can see happens over a very gradual period. And, really, in fact, it's so gradual that often we can still see constellations from the previous season just at the beginning of the next season. And so the sky can sort of bridge across seasons. And so right now we have a situation that's sort of like that. It's very, very close to that point where we can still see just barely, I should say it this way, that the constellation Gemini, which is one of the winter constellations, has just set below the horizon right about now. And of course, the sun is still up because we don't have sunset now until, 8:20, 8:25 or so. And so what that means, of course, is that we can't see that any longer. But now we have the constellations of the spring sky perfectly positioned almost directly overhead at 9 p.m. Now, that also allows us to, if we stay up a little bit later tonight, to see the coming constellations of the winter sky. Now, Dave, as you see me sitting here, you may notice that I'm gesturing in different directions. I'm sure our listeners are seeing the same sort of thing. I might point over in this direction, point over in that direction. and for me, my way of orienting myself to the sky is always around where is east and where is west. So if you're outside this evening, or I really implore you to figure out right at your location what directions are where. And the reason why is because that's how you're going to set yourself up to see the evening sky. So, I mentioned Gemini, Dave, over on the western side of the sky where the sun is setting. And that's your first clue for anybody looking at the sky, which direction is which. Now, Dave, where you live, can you identify which direction is east? I've already done the hard work for you. I've given you the direction west. Is where that big glowing thing is over
Yeah,
on the
that.
sky. Okay. How about the other side for you? Can you identify east?
Well, I can if I know where west is over there. Now watch me gesture. I want to go over there for east.
Okay, that's
Yes.
great. That's perfect. So now what you can do is you can figure out from there where the direction south is. It's going to be halfway between east and west. And all of our listeners can do the same thing. Just imagine, if you will, if you're sitting inside right now, just imagine where the sun is in your neighborhood right now. Just imagine where that is. Think about the buildings and the trees and whatever else is in the direction where the sun is setting. Well, that's the direction west. Here's the cool thing. Even after the sun sets and the sky is dark, those buildings and trees that you identified over in that direction, they'll still be there. So you can still identify that as west. And now, just like you did, Dave, imagine in your neighborhood where east is. There you have east. Now, halfway between east and west, in the middle of the day, the sun is high in the sky. In your neighborhood, imagine where that is, and that's the direction south. So now we've covered 3 directions really easily. We didn't need a compass. We didn't need GPS, no mechanical devices, not even a smartphone. So we have 3 out of 4. Last one, on the count of 3, you and I are going to point to the direction north for us. You ready?
Okay.
Everybody else out there, you can do that with us too. Okay, here we go. 3, 2, 1.
Done it. How did we do?
Hey! Hey, but I think we did all right. We'll see if anybody else can figure out where north is where they are if they're listening. But here's the cool thing about this. That orientation sets you up to follow how the sky moves. So this the horizon, pass overhead in the west and pass overhead in the south and set over. 9 p.m.,
Freezing.
halfway up the sky, looking out toward the south, you'll see the constellation Leo, Leo the lion. It's a constellation that's easily seen even under brightly illuminated skies. It's really made up of a backwards question mark on the western side, a backwards question mark, and a right triangle hard to see that. That's the main constellation of the spring sky. If you move a little bit to the west, you'll come to the constellation Cancer the Crab on the dim side. Not very easy to see. Urge to get into are some of the summer constellations just rising over on the western side, on the eastern side of the sky. Now, here's a little tip, Dave. Here we are, sort of gestures to sort of grab onto these shapes that we're mentioning. But I have a really cool suggestion for an online star map that everyone can use that will work where on your mobile phone that will help you be able to see constellations in the evening sky. It's called Stellarium. Stellarium. You can look it up at stellarium.org. It's a free download. It works really well. In fact, I have to tell you, I've sort of switched and then you'll be able to follow the sky. I'm going to recommend that, Dave.
Now, Derrick, there's something that isn't working very well at the moment. I'm hearing that it's a little glitchy. I'm being asked to know whether you can move either a little closer to the house or, gosh, maybe even inside.
I'm so sorry about that. Oh, that's interesting. Just a moment. Hold on.
Sure.
I believe I can fix that.
Okay.
Give me a second. Okay.
Good.
All right. Let's see if that works better. And if not, we can certainly move someplace else.
Good.
Okay.
Sounds great now.
I'm glad to hear that. Okay. Sorry about that. So let me know if I pause again, Dave, and we'll make some other changes.
Okay. All good now. Let's continue.
I see Donna Claiborne, my good friend Donna Claiborne, is asking. I'm looking at the chat box where we have questions. And Donna Claiborne, hi Donna. Donna says, can I please repeat the app that I mentioned? I'm sure a lot of people are asking the same question because of the glitchiness of the video.
Mm-hmm.
You still doing okay?
Yes.
Good. Stellarium. Hi, Donna Claiborne. It's Stellarium. STELLARIUM.org. Okay. All right, Dave, still there?
I'm still here. So
Great.
we're listing the constellations of note, and we'll continue with that, but I can't wait. Are there any meteor showers or lunar or solar eclipses, real rare treats to be seen?
Well, I'm very glad you asked that question. And what I'm doing right now is I'm just checking to see when the next visible pass of a satellite will be available for us to see. So what I'm doing is I'm sort of correcting my position here just to keep the sunlight out of the view. As you can see here, that's one of the issues about being outside. So yeah, there's a lot of really cool stuff that is going to be available to be seen this summer. And most prominently, one second. There we go.
Perfect.
Thank you. Most prominently in the evening sky, we're going to pick up a number of bright planets to be visible as we move into July. I don't know how you made out this spring watching Venus over in the west after sunset, Dave. Could you see that where you live?
I could.
That's good. Well, I'm sure a number of other listeners also could see it as well, but unfortunately, Venus has left us for the season. We won't be able to see it again until late this fall coming up. But Venus will be replaced with bright planets in the evening sky. The two largest planets of our solar system, Jupiter and Saturn, will make their appearance as we move into mid-July. And they'll be with us through the rest of the summer and into the fall. They'll be great to see because they are the showcase planets of the evening sky.
Now, Derrick, in a more general sense, are sky gazers advantaged this season in part because of the reduced traffic due to the pandemic? Are the skies clearer?
You know, I've heard that statement. I've heard that question a number of times about whether or not, because of the reduced activity, the skies are a bit clearer. I would say that for an urban area, any urban area, whether it's New York or Philadelphia or any place like that, there might be a slight reduction in the amount of light at night, but because so many buildings use architectural uplighting, that then causes the skies to remain fairly bright at night.
Can't overcome the light pollution.
Yes, it's a challenge to overcome the light pollution. However, you know, actually, we can do a little bit to overcome the light pollution. While we might be quarantined at home, you know, we actually can go out at night. And if you're traveling in your car, you could go to a place where the sky is clearer and darker and observe the evening sky that way, of course, maintaining your social distancing.
That's one way to do it.
It is.
Hold on one second. Okay, I'm back. And I thought I had what I needed to travel. Oh, yes. One of these and a couple of these, gloves and mask. I'm ready.
Yes. You have everything you need. Yes, you are
Yes.
ready. That's good. Good for you. That's wonderful.
Yes, indeed.
That's wonderful.
But, you know, once upon a time, just a few months ago, we were touting star parties and amateur astronomy groups. I suppose that's all in mothballs for now.
Yes, it is. In fact, a number of astronomy clubs are even hosting their monthly club meetings online in various kinds of Zoom formats, just so the membership can keep in touch with each other. But you're right, star parties, of course, unfortunately, have been sort of postponed for the moment. However, I think as we continue to figure out how to deal with the pandemic situation, we might be able to come up with inventive ways in which people might be able to be together, socially distanced, and observe the evening sky still. There are certainly ways to do that. I've been toying with some ideas about how I might be able to make that happen by using various kinds of indirect methods of observing. You know, it's not the same thing quite, but if everyone brought their own telescope to a location, then, in a sense, I suppose, we could gather socially distant together to do observing. And in the case of observing something like the sun, now the sun is always sort of a dicey kind of observation to make because you have to have the correct kind of solar filter for that. Or there's a method that can be used called eyepiece projection. Eyepiece projection allows you to project a large, dimmer image of the sun that people can look at indirectly. Excuse me. And then that way, a number of people can all observe at the same time, but safely without using an eyepiece and without looking directly through the telescope.
Also, unfortunately, I presume the Franklin Institute is not yet open for visitors, but what is going on with the Franklin for those who specifically want to learn more about astronomy?
That's a really great question. Well, we do a tremendous amount. First of all, we've created a new section on our website called Franklin at Home. So if you go to fi.edu, you can go to that section of our website called Franklin at Home. And there, what we've done is we have created and placed an incredible array of videos and activities, all related to the sciences that are our core sciences at Franklin Institute. And you can jump in there and find all kinds of great things to see and do related to science, of course. Now, some of these events are live, and one of those events happens to be a program called Night Skies at Home. And this is a mimic, excuse me, this is a mimic of our monthly program, Night Skies at the Observatory, that we've now transitioned to being at home. And the idea of that program is very similar to this. Let's take a little tour around the evening skies as if we're going to go outside to observe. And in this way, we can all become familiar enough with the sky that when the sky does become dark, or when we have an opportunity to go out and observe, we'll already be familiar with the sky. So that's a great way for us to do that.
Let's expand to, I know a lot of your work entails traveling to see the various telescope projects, frankly, all over the world, in Chile or Hawaii. Are those projects still extant and developing?
Yeah, that's also a really good question. As it turns out, a number of observatories have reduced their staff to just a skeleton crew so that they can continue to keep some of the telescopes operating, but much of the research operations have been curtailed. In some instances, some observatories have been almost completely closed down and are not operating. So, for example, the very large radio telescope array in Chile called ALMA is almost completely shut down. And that's really unprecedented in the operation of that instrument, except for perhaps technical work that may need to be done or servicing work. But in this case, the science has almost completely stopped. And that won't resume again until the pandemic situation comes to a solution that makes it possible for people to gather together to work again. So around the world, we find that even in astronomy, the pandemic has caused a lot of change in how things operate. Now, this is not true for space telescopes, obviously, in that space telescopes, being above the Earth's atmosphere, don't have to be concerned with that. But the operating stations on the ground still do need people and engineers to operate the equipment. So as we have all sort of set ourselves up so that those of us that do have to go to an office to work have figured out a way to do that as safely as possible. Those same kinds of protocols are being observed at some of the ground stations for the space telescopes.
So in that context of impediments and workarounds, all the more amazing that for the first time in, I believe, close to a decade, we finally launched astronauts from the United States to meet up in ISS. What an amazing feat.
We did. It was truly an amazing feat. You would think that we might not have been able to accomplish this given.
Oh, well, I think you're getting a tad glitchy again, but continue. That's good. No, you're a little fixed right now. Yeah. Hello? Derrick, we got a little glitch going here. Can you reposition him once again, please? Still waiting to hook back up with Derrick. And of course, you are listening to Skytalk live through WHYY. Derrick and I typically hold forth Saturday mornings, but this is a nice opportunity for an expanded version. And of course, we welcome your questions as well. Waiting to connect back with Derrick Pitts. And so while we're waiting for him to reconnect, we've been reviewing the night sky. Derrick, I see you.
Yes.
And I hear you. 2 for 2. That's great. Welcome back.
Yeah. Sorry about that.
You better be sorry. I was telling them all about you while you were away, and some of it was good. Some of it was good. Oh, no.
Actually, it's interesting because this is one of the challenges of having... What is happening here?
Of course, most of the questions that will be coming in are way beyond my expertise, but I can answer this one. Somebody asked, what time are we on typically on Saturdays? And we are typically on around 9:35.
Okay, let's try that. Let's see how that works.
Okay. No, but I still have Derrick in a fixed image. We're talking about the night sky. We're also going to be talking about the latest developments in research and astronomy, and of course, taking your questions as well. You're listening to Sky Talk Live on WHYY. Thanks for joining us on this fairly nice evening. We were thinking it would be clouding up, but it looks like we'll have an opportunity to step out of doors this evening and test some of what we're learning tonight. Waiting for Derrick to join us again. He did clear up a myth. I didn't realize it was a myth. I thought there was much less pollution now because people were driving less, but it doesn't have a dividend that pays in terms of being able to see better at night or day, the daytime sky. Hi again, Derrick.
Hello again, Dave.
So far, so good. Let's proceed.
I'm not going to move from where I am.
Okay, and I'm crossing my fingers.
Yes, I was just mentioning that unfortunately, one of the things that happens is that we have had some difficulties working from home via online connections of various kinds. My apologies to the audience. Hopefully you'll bear with us as we try to make this work. Anyway, I think what we were saying was that we were talking about the launch of astronauts to International Space Station on the new SpaceX rocket using the Crew Dragon module. Were you able to see that launch, Dave?
You bet. Very dramatic. It was so heartening in the face of all the news that otherwise is in many ways very bleak right now. It was a real triumph in the moment.
It was, and if we just think for a moment about what that mission means, it really was a test of the system to see whether or not the rocket and the capsule would perform as they were expected to, so that this system can now be used to take astronauts from Earth up to low Earth orbit. And so far, the mission is going exactly as was planned, and the astronauts reached International Space Station the next day after launch, and everything seems to have worked just the way they wanted it to.
Now, this was touted as the first private enterprise, and in a sense, that's very true. But I think I learned that even back during the Apollo program, NASA was subcontracting out to private entities parts and service for some of the components that, for example, went to the moon.
You know, that's a really interesting point, Dave. We think of this as a new era in space exploration because of the fact that SpaceX is a privately owned company that's producing the rocket launcher and producing the Crew Dragon, when in fact NASA has always been very much of a large contracting organization in which they may designate specifically what it is they need from a manufacturer, but then the contract allows the manufacturer or designates the manufacturer to do the work. So if we look back in history, I just remembered this earlier today, Dave, actually, when I think about it. Back during the Mercury and Gemini missions, the camera views that showed what was then called the White Room, the area where the astronauts were being inserted into the space capsule. I don't know if you remember any of those scenes or not, but the engineers wore shirts, and on the back of their shirts was printed the name of the company they worked for, McDonnell. Some of our watchers this evening might remember that. And that name, McDonnell, was one of the big names in aerospace in the 1950s, 60s, and 70s. So NASA has always contracted out the work. It's just that now we seem to be more aware of the commercial nature in that this company is one that comes not from a background of aerospace, but just from the desire of one person, its Chief Executive Officer, Elon Musk, to want to figure out a way to provide regular, lower cost, reliable access to low Earth orbit.
Derrick, we did just get a related question, and it's a good one. Where exactly is International Space Station? Is it at a prescribed orbit, or is it kind of free form to go wherever it wants?
Yeah, that is a really great question. No, International Space Station is on a prescribed orbit. I believe the inclination of the orbit is 51 degrees above, 51 degrees away from the equator. So it is constantly orbiting on that path around Earth. If you were to look at a map of the orbits of International Space Station, it would look like a sine wave, like a wavy line going across a sort of like a Mercator projected map of the planet. Well, what that map shows is the rotation of the Earth underneath the spacecraft as it orbits around the planet. So while the orbital path is constant, the Earth's rotation underneath it makes it visible across the planet at different times. So it's always in the same orbit. And if a space capsule is going to try to go up to International Space Station, it has to match the same inclination of orbit, and it has to match the same velocity, and eventually catch up with space station.
When did International Space Station first launch?
Oh, let's see. International Space Station is now 20 years old, believe it or not. Yes.
Wow.
It's been there for quite some time. And the way I like to say this, Dave, is if you really think about space exploration, human space exploration in this model of the space station, if I'm not mistaken, there hasn't been a day in the last 25 years where people have not lived and worked in space on a regular basis, like every day. And so this counts not just International Space Station, but it also counts the Russian space station Mir that American astronauts used to visit and work on before International Space Station was launched and built.
How long will this new crew be aloft?
Well, this new crew, the two astronauts that went aboard on that mission, their major task was to, shall we say, trash out the Crew Dragon space capsule.
Mhm.
They were to sort of like put it through its paces and give it some testing and see what it was like to fly and things of that sort. So they took a trip that brought them to International Space Station just the next day after they launched from Kennedy Space Center in Florida. They'll be at International Space Station for a minimum of 6 weeks. They could possibly be there longer, but NASA has yet to announce how long their portion of the mission will be. They've become part of the crew that's on board International Space Station now, which is called Expedition 63, and that's comprised of 3 astronauts. So altogether right now, there are 5 astronauts on board International Space Station.
3 Americans.
So after a little while, yes, 3 American astronauts on board. And so what will happen is after 6 weeks or so, the astronauts that took Crew Dragon up will bring it back to Earth so that they will be able to test its re-entry systems and its splashdown and recovery systems as well. So it will have been a full ride all the way around for the Crew Dragon and the astronauts that flew it up to International Space Station.
If the duration of their tenure extends through the fall, will they be able to vote by email if it's their pleasure?
Well, it's funny that you bring that up because, as it turns out, astronauts always vote from space by mail. So while we may have seen all sorts of memes in our social media about how if it's possible for us to submit our taxes by mail and do everything else by mail, surely we can all vote by mail just as well. Astronauts have been doing that all along. They always vote by mail from space if that's where they are at the time when it's time for them to vote.
NASA is obviously dependent on U.S. Congress for their funding, and that we are in this fraught economic time. Is there real concern that there might not be too much more happening? Before this, we were talking again about going back to the moon and thinking about going to Mars in a manned space venture. Is that all on hold now?
No, in fact, it isn't on hold. What's happening with that is that one of the things that's actually really crucial for NASA is to have dedicated ongoing funds to support what it wants to try to do. Unfortunately, what has happened over time with NASA is that the goals and objectives, along with the funding, have changed with the whim of the president. And that's unfortunate because to develop a successful long-term space program, we need a long-term commitment with dedicated funds that aren't changed every 4 years. And so in this particular case, what's happened is that the current administration has agreed to a budget for NASA that will allow it to develop the program of going on to the moon and then possibly going on to Mars, at least through this administration. So that dedication is there. And hopefully what has happened is the budget will be set so that the next administration would also agree that this is a good thing for NASA to do. It's a good thing for the country to do. And so the budget won't be disturbed and the mission will stay the same. So far, everyone seems to agree that this is the correct path for NASA to take. But we should also be aware that this path was established in previous administrations of both the presidency and in the management of NASA. So it's really taken almost a decade for us to get to this point. After the end of the Space Shuttle program in 2011, we had to power NASA up to come to the point where it is now. And of course, it's going to take at least another 15 years to mount a mission to head out to Mars.
Now, you have allowed that there's nothing like the romance of man exploring the heavens above, but better science can be done much more reasonably in terms of cost through unmanned missions. Is that correct?
Well, if we used, yes, you are correct about that. Using unmanned uncrewed missions, we reduce a tremendous amount of cost. It doesn't cost anywhere near as much if humans don't travel along. And the other thing is that the risk that's involved, that something terrible can happen, that there can be loss of life, really is completely eliminated. And so that's a very attractive option. And in that way, not only can we save money in that method, the other great thing is that should anything go wrong with the mission, we don't have to worry about loss of life. But at the same time, we lose a tremendous amount because no matter how good the sensors are, no matter how good the computers are, none of that machinery can integrate data on the spot as well as humans can. And so this is the tremendous value and often is worth the risk of sending astronauts into space to do exploration because of the way that kind of synthesis can be done. So at the same time, I think we also have to admit that humans are in many ways born to
learned this from you over
explore.
the years that don't, but this questioner wants to know how we know we can see ISS. How can we identify that in the night sky? Is it a twinkler or a steady light?
It's actually just a steady light. It moves across the sky at a regular speed, and if you go out to see it at the correct time, you can see it without any difficulty at all. While we're doing this, I'm not going to lose you, but I'm going to find out when the next time is we're able to see International Space Station, and hopefully we'll be able to send you out to see it sometime this weekend. And when you go out to look for it, all you need to know is the exact time when it will appear, what direction it will appear from, and how long it will be visible. And then when you go out at that time, you can watch it as it moves across the sky as just a bright dot of light.
In a general sense, how long is it visible before it traverses the sky and is out of your line of sight?
Well, it can be as long as almost 8 minutes. I think the longest view I've ever seen is just under 8 minutes long. But it might also be visible for just 1 minute. And there are conditions for when this is, what the best time is to see International Space Station. And those best times are just after sunset as the sky is getting dark. So right now it's 7:37 p.m. The sky isn't dark enough to see International Space Station yet. The sun doesn't set until nearly 8:30 this evening, and so that means we'll have to wait until about 9 o'clock. That's when the sky will be dark enough. But at that point, that's a good time to see it. Between, until about 3 hours after sunset, maybe 3.5 hours after sunset. An interesting thing happens after that point, Dave. What happens is that the Earth, or our portion of the Earth, has rotated into the Earth's shadow, rotated into dark enough that space station, even though it might be flying over your area, is not catching the light it needs to reflect down to you on Earth in order to see it. So we only see it through the virtue of reflected light from the sun.
And is that indeed why stars twinkle and planets don't? Planets don't because it's reflected light?
Well, that's also a really great question. As it turns out, it's a little bit different from that. Stars, or the starlight that we see coming to Earth, comes over a tremendous distance, tens of light years, maybe even hundreds or thousands of light years. Well, that light coming from such a long distance has had to interact with a number of different obstacles along the way. And then finally, that light comes to our atmosphere with its different temperature layers, and those different densities of air, because of the different temperatures, causes the light to sort of break up and wiggle around a lot. Well, that's from a pinpoint light source like a star. A planet, being much closer to us, has a much denser stream of light that can get through the Earth's atmosphere with much less degradation. So for us, planets appear as bright dots that don't twinkle. And so that's how we can say stars twinkle but planets don't. So if you're outside in the evening trying to figure out the difference between stars and planets, the easiest thing to do is to note whether it twinkles or not. If it doesn't twinkle, it's a planet. And then the planets are easy to identify from that point on.
And so you mentioned Jupiter and Saturn, and we talked earlier about Venus. What else? How about Mars, the red planet? Is that available to be seen?
Actually, it is available to be seen. Right now, it's in the pre-dawn sky, in the morning before sunrise. You can actually see those 3 planets right now, Mars, Jupiter, and Saturn, but you'd have to be up very early in the morning. Because the sun is now rising pretty early in the morning, around a little after 5 a.m., That means you have to be out at, say, 4:15 in the morning in order to have an opportunity to see those planets over in the east and southeastern portion of the sky. But it would be rewarding if you did that right now. And the reason why it would be rewarding if you did that now is because you could go outside in the morning before sunrise and you could see those planets. And then what you could do is you could wait a few weeks and then see them as they creep into the evening sky in July. So that would give you a chance to see them on both sides of the sun, if you will. As we orbit the sun, we see them first from one vantage point in the solar system, and then the Earth swings around over the course of the weeks and months, and then we see those planets from a different vantage point.
Changing topics for a moment, let's empathize with the many sports fans in Philadelphia, Eagles, Flyers, Sixers, Phillies, and we think of ourselves as a sports town. You've alternately posited that we are also truly a science town and a science region, and now with sports not yet emerged from hibernation, perhaps all the more so. Explain.
So, right, we've often talked about, or it has often been said that, as you've pointed out, Philadelphia is such a sports town where many of us are in love with the sports teams we have here. We know so much about the sports. We know so much about the athletes. Yet we don't realize the degree to which science plays a huge role in the city. We don't realize how much science is actually happening in the city. In fact, in terms of astronomy, there is a tremendous amount of really cutting-edge astronomical research going on here in the Philadelphia area. Just a couple of weeks ago on my Night Skies at Home program, I had a guest from the University of Pennsylvania, an astronomer named Mark Devlin. And Mark is a research astronomer who builds equipment to detect information from the most distant portions of the universe in an effort to better understand how the universe came into existence and how it's growing and changing. He's building what are essentially cutting-edge instruments that have never been created before. He's building them in his labs at the University of Pennsylvania, working with graduate students to put together these devices that will collect this information. These then incredibly unprecedented pieces of detective equipment will then go to particular sites on the planet where they can be set to look at the night sky and pull down this tremendous information. This work, while it's being done by a consortium of astronomers from around the world, these devices are being created here in Philadelphia. And so this is really deep astronomical research in an effort to understand not just something so esoteric, but something that will help us to better understand how the universe works. And I think we should be tremendously proud of the fact that this happens in Philadelphia. And that's just one example of the great work that happens here. So I think of Philadelphia as a science city as much as anyone else thinks of it as a sports city. And then, of course, as I always say, with science, you can't lose.
You never lose. Amazing that Mark Devlin, in this case, might have greater acclaim outside our borders in our region than here in the Philadelphia area. It's very interesting.
Yes, it is very interesting. You're right. And I highly recommend that we tell more stories about some of the tremendous science that's happening in the Philadelphia area. I'm just checking my other devices here. Sunset tonight is at 8:29 p.m., just 8:29, and the sky will then be dark at around 9 p.m. And this leads me back to something else, Dave. Today is June the 10th, and at 8:02 p.m., we won't be able to see it quite. There is an International Space Station flyover over this region. Oh. It's not very high up, so I'm going to go on to, let's do tomorrow night and let's do Friday. Tomorrow evening at 7:49 p.m., I'm just looking to check and see here the times I have here. I know what I need to do. Let me do one other thing. Folks, we're doing this on the fly, so I hope you'll have patience with us as we get this together. Here we are. Okay, I'm just looking to see. Yes, okay, so here I am looking now. The next visible passes of International Space Station. Listen up, folks. This is important information. The next visible passes of International Space Station actually occur between the 20th. I'm looking at the period between June 20th,
Mm-hmm.
which by the way happens to be the first day of summer, June 20th and June 30th. I have 3 passes on the 27th, 28th, and 29th in sequence, and they're all very early in the morning. The best one of these is June 29th at 4:17 a.m. International Space Station rises in the southwest, passes overhead in the southeast, headed up toward the northeast. So it comes diagonally across the sky from the southwest, across almost the top of the sky, Dave, at 76 degrees up, and then disappears over in the northeastern portion of the sky at 4:23 a.m. So that's a 6-minute pass. It'll be very, very high and very easy to see. The only catch is it's at
4:20 in the morning. Exactly.
So for anybody who happens to be up at that time, you can see this also. Now, the important thing that you need to know is where am I getting this information from so that you can go to look up this information for yourself. I use 2 websites. One is called heavensabove.com. That's heavens-above.com. And the dash between heavens and above is very important, so don't leave it out. heavens-above.com. That's a really great website that will give you information for all kinds of satellites that are visible. And I have one other one that's a much more graphic description of when satellites are available to be seen. You can search this one very easily. It's called See a Satellite Tonight. If you search for See a Satellite Tonight in your web browser, you'll come upon this really, really cool satellite spotting app. And here's what it does. It shows you a view of where that satellite is passing over the Earth relative to where you are. It uses the GPS of your location for that. But then what it cleverly does is it uses Google Street View to show you where the satellite would be visible in the sky in your neighborhood using photographs from Google Street View in a split screen. So I think that's a really, really lovely graphic way to help you figure out where in the sky to look for satellites. Now, space station, not going to be visible in the evening for a while. It's going to be visible in the morning sometime next week. But try See a Satellite Tonight anyway to see what other satellites are available tonight and over the next 7 days.
There are thousands and thousands of satellites, and to the point where we've also talked about is there any kind of recycling system to get some of these defunct ones out of the way?
Engineers are beginning to work on figuring out how they can try to clean up the space junk that is in orbit around the planet. Depending how you measure the objects in orbit around the planet, you could say that there are anywhere from 10,000 objects up to probably 30 or 40,000 objects in orbit around the planet. And that's if you go by size. Now, are there a lot of big things? Not a lot of big things, but there are some big hunks of material left over from rocket boosters in stable orbits around the Earth. There are also absolutely thousands of much smaller items that are the result of spacecraft separating from each other and, that sort of thing. So it's of concern because these objects traveling around in orbit, Dave, have to travel at very high speeds to maintain their orbit. So imagine something the size of a kitchen trash can, for example. Everyone can envision that. Imagine something like that traveling at 17,500 miles per hour. Well, that mass carries a tremendous amount of force, a tremendous amount of energy bound up in it because it's moving so fast. If it were to strike something else, there would be a catastrophic explosion of parts of both of those objects being blown to pieces. Now what we've done is we've created a cloud of hundreds, maybe thousands of more pieces traveling at that rate of speed. Now that hasn't happened in space very often yet at all. It's happened probably 2 or 3 times that we know of, but what we want to avoid is having that happen more often because that might create a chain reaction of those kinds of interactions occurring, and we really wouldn't want that to happen. So what are we doing about this? Here's what we're doing. SpaceX is a really good example. What they've done is they actually reuse their boosters. They provide enough fuel for their booster rockets to be able to come back to Earth and land near where they took off or land on a barge out in the Atlantic Ocean. That way, that booster isn't still in orbit and they can reuse it. And the plan is the same for almost all of the equipment that they use. That drives down the cost of getting into space, and it helps to clean up space a little bit. Some other engineers are working on plans to either use a gigantic net to grab stuff, or maybe to use little rocket motors on a separate package to attach to a piece of defunct space junk and gently nudge it so that it falls into the Earth's atmosphere, where, for the most part, these things can harmlessly burn up or maybe fall into an ocean someplace. That doesn't do a whole lot for our oceans. We really don't need to be dropping more stuff into the oceans. But if we could manage to steer them away from Earth, put them on a separate course for another part of the solar system, like into the sun, for example, it still would take a lot of energy to do that. But at least that's a better alternative than having it crash down on Earth somewhere we'd rather not have it crash.
Derrick, I want to again encourage viewers to ask questions, and I will lead by example to prove that no question is too simple. You've cited sunrise and sunset, but yet clearly it's still a little bit light after that sunset time. You cited 8:29, and sunrise, the sky is already lightening. Is it merely the point that the sun is first visible on the horizon?
Yes, when we talk about Yes, that's right. When we talk about sunrise or sunset, we're talking about an instant, about when the sun is crossing the horizon. That's what we're talking about. But what happens, though, in the morning, we can see the glow of coming sunrise much earlier than sunrise typically occurs. So, for example, one of the things I monitor is something called twilight. Everybody knows what twilight is, but many people don't realize there are 3 stages of twilight. There's what's called civil twilight, let's use sunset for example. Civil twilight is when the sun is 6 degrees below the horizon. Now for us, civil twilight tonight will end at 2 minutes after 9. Then 12 degrees after, as the sun drops 12 degrees below the horizon, we have what's called nautical twilight. That happens at 9:43 tonight. And then there's astronomical twilight, when the sun is 18 degrees below the horizon and we consider the sky to be dark. That happens at 10:31. Now, we don't have to wait that late for the sky to be dark as we perceive it. We'll perceive the sky as being dark at nautical twilight at 9:43 this evening. So we get the reverse in the morning when the sun is rising. First is astronomical twilight, then there's nautical twilight, then civil twilight, then sunrise.
Derrick, we've just gotten another fascinating question on a slightly different topic. We've talked about the light from stars could be tens or hundreds or thousands or whatever light years away. So the question is, how do astronomers know when a heavenly body no longer exists, if what we're merely seeing is its light that emanated a long time ago?
I love that question. That's a really cool question. How do astronomers know when something is no longer there? Often it depends on what the object is. If it's a star, we are really, really fortunate if we can see when a star winks out. Now, the most catastrophic way for that to happen is if the star blows up in a process that's known as supernova. If a star explodes, boy, that's really an event to catch. And we've seen that a few times. We certainly have record of it having happened, but we've been able to actually directly observe it almost exactly when it happened. I think only once, actually. But we can look around the sky and notice that stars have, exploded, because we now find a very bright star in a portion of the sky we didn't expect to find a really bright star. So we know that something has happened in that way. But it's difficult for us to tell, because if a star is so far away, we may not be able to see it to begin with. But let's just work with the stars that we can see. We'll know that that star has gone out if we can no longer see it. And we can also look at the type of star it is and estimate from its type how long a life it has. We can also look at that star very carefully and analyze its chemical composition to tell us how far along that star is in its life. And that will also give us an idea of how much longer that star will be around. So through some very, very clever detective work, astronomers can figure out approximately when something might happen. But let's not forget, Dave, this is on an astronomical time scale. So we might say it's going to happen 10,000 years from now, but it's the universe. It could be 10,000 years after that, or 5,000 years before. Anyway, it's 5 to 10,000 years from now. So that really complicates when we might be able to actually catch something happening.
Derrick, here's something complicating. I'm looking at the clock and we just have a few minutes left. So let's go to the speed response because the questions are coming in. Here's a true
Let's
false.
do that.
Heard something about a comet being visible in June. True or false?
Comet Atlas. Comet Atlas was supposed to be visible. It was visible this past month in the pre-dawn sky. It wasn't as bright as people would have hoped it would be, but it was there nonetheless. There's still plenty of other comets around the sky. It's just a question of whether they get up to naked eye visibility to make them spectacular to see in the sky. Next.
Here's a personal question for you. What is your favorite planet and what is your favorite constellation?
So my favorite planet actually is, for looks, just for sheer looks alone, Jupiter. I love looking at Jupiter because the cloud patterns in the atmosphere are so complex and so dynamic. But I would really rather go to Mars rather than go to Jupiter. And the reason why is because I can walk around on the surface and I can explore the geology. What's my favorite constellation? Wow, that's a great question. Do I have a favorite? I don't think I do. But Orion is always a really good one. That constellation of the winter sky is intriguing because it has such a great combination of different stars and nebulae available to explore.
And now let's see how quickly you can talk. Answer this question that came in. What is dark matter and what is dark energy? Go.
Oh, dark matter and dark energy are two components of the universe that seem to have much of the mass of the universe tied up in them, and the dark energy in the dark matter portion, and the dark energy portion happens to be, or we think it's that energy force that's helping the universe to expand as it ages. That's pretty quick for those two. Didn't cover all the bases, but it got a good bit in there. And
that is pretty quick.
And I have to say one other thing. I know we're going to head out pretty soon, but one other thing I have to say is I have to say hi to my good friend Martha, who is listening to us from Maui, Hawaii. Hi, Martha.
Martha,
thanks
my
for joining
dear.
us tonight.
Hi. So that dark matter and dark energy, is that just like a little accent point in the universe? Like what % of universe is the stuff that we know versus dark matter, dark energy?
And that's the best question and probably one of the most amazing things of all. As it turns out, dark matter and dark energy make up 96% of the matter of the universe, of the stuff of the universe. They make up 96%. Yes, the other 4% is all of what we see in the universe, the planets, the stars, the galaxies, the nebulae. That's what that's composed of. So here's the question I have. Is it that the dark matter and dark energy actually are the process of the universe, and this stuff, the matter that we have, is just what's left over from that? If that's the case, that tells us that the universe is something entirely different from what we expected. We're not the focus of the universe. The matter isn't the focus of the universe, but the dark matter and dark energy could be the focus of the universe. And this material that we see is just what's left over from that process. That's just my way of entertaining that as a possibility.
You know, when we conclude these broadcasts, I'm always motivated to say the same line. Thank you for bringing the heavens down to earth. Now you've supplanted it with another buzz phrase of yours. It's your universe, explore it. But how do we explore dark matter and energy if we can't even detect it and see it? What evidence do we know that it exists?
Well, here's how we do that. We just look at the entire matter and energy budget of the universe. And what we see is that motions in the universe don't seem to follow for the amount of mass that we have. That equation is out of balance. So we know that there must be a lot more matter someplace, and it must be invisible because we seem to have been able to account for everything we can see. So we figure there must be some dark stuff out there that's causing what we see to move the way it does. Now, in order for us to see it, we can look at how it affects other things. Don't look at it directly, but look at how it affects other things. And that helps to tell us that there's something spooky going on out there in the dark at night.
So we know that matter matters, we just don't know the extent. Here's a question, and this is one that I love. Somebody wants to know, when's the next webinar? Did we sign up for a nightly broadcast? What's going on with this?
hey, gee, that would be fun, but I think maybe weekly would be the way to do this. And then that way, what we could do is keep people up to speed with what's happening in space and astronomy, and also point out things that they can see coming up for the next week or so. Add to that is that we can answer more of your questions. That's really what we love to do, is to make sure that you get your astronomy and space science questions asked and answered, and at least maybe perhaps even give you something more to think about when you step outside at night and look up into the sky. We want you to wonder about what's up there. After all, as I say, it's your universe. Explore it.
The ever unflappable Derrick Pitts, chief astronomer at the Franklin Institute. We threw a lot at you tonight, and you're ready to come back for more. That's really great.
I want to thank the audience for joining us tonight. We really do appreciate you being here with us, and we love your questions. So send us more questions. We hope you'll see you again.
And on a personal note, although it's nice seeing you in postage stamp size, I really miss seeing you each week and doing our Sky Talks in studio, and I can't wait for, I don't even want to say return to normalcy, because there's going to be a whole new normal, but however it's going to be, I hope all's going well with you.
Thank you, Dave, and same to you. When I come over to the station to do the programs, we have so much fun doing everything else. And then, oh, by the way, we do a radio show too.
Oh, yeah, that too. Thanks, Derrick. Have a great evening.
Thanks a lot, Dave. Great to be here. Great to see you. Look forward to seeing you in person soon. Good night, everybody. And don't forget, look up.
You're leading by example. I'm heading out of doors right now.
Excellent. I'll see you out there.
See ya.